Datascope is proud to introduce the CS100 Intra-Aortic balloon pump with its newest feature, IntelliSync software. The CS100 offers high operational flexibility to aid your medical staff in supporting a broad range of patients. Designed to work in conditions that are unique to the operating room or catheterization laboratory, the CS100 is also easy to operate in a critical care unit and in emergency transport. This compact system combines speed with smart algorithms to quickly apply support to patients with difficult dysrhythmias. Ease of use has also been greatly enhanced by a system design that employs a large articulated color display to monitor pneumatic and electronic innovations, and a host of automated features. IntelliSync software with CardioSync 2 incorporates auto-trigger and auto-timing selection, continuously monitoring and adapting to the patient's rhythms to provide better tracking, triggering, and support of isolated PVCs, ectopic patterns, and atrial fibrillation. Many published reports have documented the efficacy of IAB catheters in general and Datascope balloon pumps specifically in an ever-growing number of clinical situations. Typically, the intra-aortic balloon catheter is inserted percutaneously through the right or left femoral artery. The balloon is positioned in the descending thoracic aorta, just distal to the left subclavian artery. Significant beneficial effects may be realized by inflation and deflation of an intra-aortic balloon, IAB. However, the balloon's inflation and deflation must be properly synchronized with the cardiac cycle. To achieve maximum benefit, the IAB inflation is initiated at the onset of diastole, at the dicrotic notch. Inflation of the IAB is sustained throughout diastole and is deflated at or just prior to the onset of systole. The balloon is held in the deflated state throughout systole. Coronary perfusion is increased by augmenting blood pressure during the diastolic phase of the cardiac cycle. This increase in aortic pressure forces more blood through the coronary arteries. While coronary blood pressure is increased during diastole, blood pressure during the systolic phase of the cardiac cycle is decreased, and the workload on the left ventricle is correspondingly reduced. Precisely synchronized IAB inflation reduces myocardial oxygen demand, increases stroke volume, improves ventricular emptying, and results in an overall improvement in cardiac output. The CS100 has 3 operation modes: auto, semi-auto, and manual. When the auto operation mode is selected, all aspects of IABP operation are automated. The CS100 automatically selects the best available trigger source and automatically sets IAB timing. In the event of a loss of trigger source, that is, a lost ECG lead, the CS100 will sequentially search for the next best available trigger source and then reset timing accordingly. Timing is continuously assessed and is reset if the patient's heart rate or rhythm changes. As the name indicates, semi-auto operation mode provides partially automated operation. The operator is responsible for both selection of the trigger source and for initial timing of the IAB. Thereafter, the IABP's timing algorithms will adjust timing in response to changes in heart rate and rhythm. Of course, if the trigger source is lost, the IABP sounds an alarm. This operation mode provides the most flexibility for difficult cases. In the manual operation mode, the operator is responsible for selection of the trigger source and setting IAB timing. The operator is also responsible for maintaining correct timing in the event of a change in patient heart rate and rhythm. The CS100 features a rapid startup feature which employs sophisticated algorithms that allow the medical staff to concentrate on the needs of the patient instead of the needs of the pump. Immediately on powering the rapid startup feature, the CS100 automatically selects the auto operation mode, purges and fills the IAB, selects the best available trigger source, starts assist, and automatically sets IAB timing. Of course, it is recommended that the operator assess the resultant timing after the rapid start process completes. Inflation timing is automatically set. However, deflation timing practices can vary considerably. Therefore, even in the auto operation mode, the user can adjust the deflation timing if desired. The system can be divided into two subsystems, the electronic system and the pneumatic system. The electronic system consists of the color monitor and its controls, the dual-channel recorder, and the balloon pumping controls. Providing maximum flexibility, the monitor module can be rotated and positioned for visibility from almost any angle, or even removed and mounted remotely. The monitor displays ECG and arterial pressure waveforms, as well as key pressures and essential data. The controls for the monitor are located below the monitor screen. In the upper left-hand corner of the screen, brief alarm messages are displayed, alerting the operator to significant clinical conditions and pump functions. In the Advisories section of the monitor, the less immediate messages, alert, status, and prompt are displayed. Up to 3 advisory messages can be displayed simultaneously. The pneumatic system is formed by the balloon catheter within the patient and a unique safety disc condensate removal module. The safety disc is composed of 2 symmetrical halves separated by a polyurethane diaphragm. The patient side of the safety disc is filled with a fixed volume of helium. Pressure and vacuum are alternately applied to the drive side of the safety disc, forcing helium back and forth between the balloon catheter and the safety disc. At the onset of diastole, pressure is applied, causing inflation of the balloon. Vacuum is applied just prior to the next systole, causing deflation of the balloon. Every 2 hours, the autofill will purge and refill the patient's safety disc system. During this time, pumping will stop and the autofilling message will be displayed. The condensate removal assembly automatically removes condensate from the pneumatic system. This results in improved pneumatic performance and reduced operator intervention. Setup of the CS100 is quick and easy. Plug the line cord into an appropriate AC power outlet, making sure the power cord is attached to the rear of the pump and that the main switch is in the on position. This connection supplies power to the system's batteries. Therefore, confirm the connection by checking that the battery charge indicator is illuminated or flashing. Now, press the system power on-off switch to on. This starts an internal check of both the pneumatic and electronic systems. This test takes approximately 10 seconds. When this check is completed, the message "System Test OK" will be displayed. The help screens are now available for use in setup. Open the helium tank by rotating the provided tank wrench counterclockwise and verify helium pressure. The pressure gauge at the rear of the pump and the helium icon here on the monitor will then indicate the level of helium in the tank. Plug a Datascope-compatible ECG cable and pressure transducer into the back of the CS100 to establish ECG and arterial pressure. ECG lead and gain are displayed on the left side of the monitor. In the auto operation mode, the pump will automatically select the best ECG based upon available sources, leads 1, 2, 3, external. In the semi-auto or manual operation modes, ECG lead or external monitor is selected by accessing the ECG AP sources key. In general, lead 2 provides the best R wave for triggering and is the lead that is automatically selected when the pump is turned on. Pressure source is displayed on the left side of the monitor. No zero will appear next to systolic pressure on the right side of the monitor screen. This indicates that the transducer must be zeroed. To zero the transducer, open the transducer to air and press the zero pressure key for 2 seconds. Close the transducer to air and note that systolic, diastolic, and mean pressures are now displayed. In the auto operation mode, the pump will select the best pressure based upon available sources, transducer or external. In the semi-auto or manual operation modes, the pressure source of transducer or external monitor is selected by accessing the ECG AP sources key. Attach the IABP catheter and the appropriate extender to the safety disc. Now, refer to the monitor where the arterial waveform is displayed. The width of the intensified portion, as indicated by the graduated horizontal line below it, represents the period of time the IAB will be inflated. In the auto operation mode, Timing is automatically set by a unique timing algorithm. For IAB inflation, no operator intervention is required. For IAB deflation, the user can make modifications, but these are not required. To begin cardiac assist, press the Start key, which will initiate the autofilling sequence. Confirm that the autofilling is in progress by looking here on the monitor screen. The word autofilling should be posted in the advisory field of the display. During autofilling, the balloon catheter circuit will be purged and filled with a calibrated volume of helium. This process is then repeated one more time before assist begins. Upon successful completion of autofilling, the autofilling message on the monitor will clear, and the Start key indicator, here, will flash with each inflation cycle. The CS100 will begin pumping with its augmentation level set at maximum. After 1 minute of assist, verify that the AUG alarm limit determination, here, on the display panel, is approximately 10 millimeters of mercury below the patient's diastolic augmentation pressure as displayed here. The system and its alarms are now fully functional and should require minimal operator intervention. The only intervention now required is for occasional troubleshooting. Although the occasion for troubleshooting is infrequent, the competent operator is encouraged to become familiar with the following procedures and to consult the printed operating instructions for additional details. Any alarm or advisory condition encountered by the CS100 will produce an alarm, alert, status, or prompt message on the monitor screen. Each alarm automatically produces a help screen that offers the user a probable cause for the alarm, as well as recommendations for corrective actions. The content of each help screen is context-sensitive and based on the specific alarm message displayed. Detailed information on all alarms, alerts, and status prompts is provided here in the CS100 operating instructions for further reference. Advisory messages are categorized into alarms, alerts, and prompts. Because of their serious nature, alarm messages signal the operator with a steady, audible tone, and IAB pumping is suspended. An alarm message is displayed here in the Alarm Messages section of the monitor screen. During alert conditions, however, IAB pumping is not suspended, but a double beep tone signals the operator that immediate corrective action is required. Concurrently, an alert message is displayed in the advisory section here on the monitor screen. Status and prompt messages do not sound a tone and are merely advisory in nature. Status and prompt messages are also displayed in the advisory section of the monitor. Because of their seriousness, all alarms immediately suspend IABP assist and sound a steady alarm tone. There are two general categories of alarms in the CS100. Trigger alarms, which relate to the electronic system of the pump, and catheter alarms, which relate to the pneumatic system of the pump. There are 5 types of trigger alarms: no trigger, poor signals persist, no pressure trigger, check pacer timing, and trigger interference. The occurrence and response to these alarms differs somewhat depending on whether the system is in auto operation mode or semi-auto and manual operation mode. For instance, no pressure trigger, check pacer timing, and trigger interference occur only in semi-auto or manual mode. A trigger alarm indicates that the selected trigger source is either not available or not reliable. Although IAB assist is suspended during a trigger alarm, pumping will automatically resume once the trigger has been re-established. When operating in the auto operation mode, a no trigger alarm is probably caused by a valid ECG and arterial pressure trigger being lost or non-existent. If a no trigger alarm is sounded, the operator should reattach or reposition the electrode and check the integrity of all cable and lead connections. Attempt to restore AP pulse height by flushing the circuit and verify the transducer was not left vented. If the alarm condition persists, switch operation mode to semi-auto and increase the ECG gain setting in the Pump Options menu here. Finally, use IAB inflation and IAB deflation controls to manually adjust timing if necessary and resume pumping by pressing the Start key. If a poor signal persists alarm is indicated, then the probable cause is due to the ECG and arterial pressure signal being poor for a sustained period. If a poor signal persists alarm is sounded, the operator should attempt to restore AP pulse height by flushing the circuit, verify the transducer was not left vented, and check the integrity of all cable connections. Then, attempt to improve the ECG signal by ensuring that the electrode is making good contact and is optimally positioned. If signal problems persist, switch operation mode to semi-auto and verify trigger source. Finally, use the IAB inflation and IAB deflation controls if necessary here to manually adjust timing and resume pumping by pressing the Start key. When operating in the semi-auto or manual operation mode, if the message displayed is no trigger, then the probable cause is that a valid trigger does not exist or is lost in either the ECG or pacer trigger mode. To respond to a no trigger alarm in semi-auto or manual mode, the operator should first reattach or reposition the electrode and check the integrity of all cable and lead connections. Then, turn to the ECG AP Sources menu here to select an alternate ECG lead selection or select external ECG as shown here, if appropriate. Next, adjust the ECG gain by accessing the Pump Options menu. If the alarm persists, select a different trigger source entirely by using the Trigger Source arrow keys here. Then resume pumping by pressing the Start key. If the message displayed is no pressure trigger, then the probable cause is that a valid trigger is unavailable or lost while in pressure trigger. If a no pressure trigger alarm is sounded, the operator should first verify that the desired pressure source, direct or external, shown here, is selected. Use the ECG AP Sources menu here to select the pressure source. Next, verify that the transducer was not left vented and check all transducer cable connections. If pressure trigger is still required and manual threshold is selected, reduce the pressure trigger threshold by using the Pressure Threshold submenu from the Pump Options menu as demonstrated here. It may be appropriate to select a different trigger source entirely by using the Trigger Source arrow keys here. Then simply resume pumping by pressing the Start key. If a check pacer timing alarm sounds, the probable cause is a patient that is not 100% V-paced or AV-paced. For the check pacer timing alarm to sound, the V-pacer rate must be greater than 185 BPM and the AV pacer rate must be over 125 BPM. If a check pacer timing alarm is encountered and the patient is on demand pacing, the operator should select the ECG trigger source using the Trigger Source arrow keys here. In any case, respond to the alarm by reducing the pacer rate. If the CS100 sounds a trigger interference alarm, the probable cause is electrosurgical noise, or ESU, that has been detected while the pacer trigger source is selected. This alarm will clear itself and automatically resume pumping as soon as the interference clears. If the alarm persists, the operator should select the pressure trigger key using the Trigger Source arrow keys. Then, verify timing and press the Start key to resume pumping. You have now been introduced to a selection of the alarms which derive from the electronic system of the CS100. The second category of alarms is catheter alarms, derived from the pneumatic system of the CS100. The CS100 continually monitors many specific parameters of the pneumatic system, from the pump to the catheter within the patient. If a change is detected or a specific parameter is violated, IABP assist is suspended, and a continuous alarm tone is sounded. The 6 principal catheter alarms are leak in IAB circuit, rapid gas loss, IAB disconnected, check IAB catheter, blood detected, and autofill failure, no helium. There are 3 probable causes for the alarm screen to display leak in IAB circuit. These are a small leak or gas gain in the IAB circuit, a loose connection, or a high rate of helium diffusion. If the alarm sounds and the screen displays rapid gas loss, then the cause is most likely due to a large leak in the IAB pneumatic circuit. The third gas loss alarm is IAB disconnected. This alarm indicates a high probability that the IAB catheter or extender tubing has somehow become disconnected from the pump. Datascope recommends the operator take the following actions for any of these three alarms. First, inspect the IAB and catheter extender tubing for any evidence of a leak. Next, examine the safety disc condensate removal assembly connections, IAB catheter connections, the autofill tubing, and the drain port. Next, check carefully for blood in the tubing. If blood is observed within the catheter or catheter extender tubing, stop pumping and notify a physician immediately. Warning: if blood is observed within the catheter or catheter extender tubing at any time during the IAB procedure, stop pumping, notify the physician immediately, and prepare for IAB removal. Before resuming cardiac assist, verify that all the connections are leak-free. Then, if instructed, fill the IAB by pressing the IAB fill key here for 2 seconds. Then, resume pumping by pressing Start. The remaining 3 pneumatic system alarms are check IAB catheter, blood detected, autofill failure, no helium. If the alarm check IAB catheter is presented, 3 possible problems may exist. Either the IAB membrane is not completely unfolded, the IAB remains in the sheath immediately after insertion, or there is a kink in the IAB catheter or tubing. Each of these possibilities relates to a helium gas restriction. Therefore, the operator should check the IAB catheter and tubing to identify the specific cause of the helium restriction. After ascertaining and correcting the cause, press the Start key to resume pumping. The alarm message "Blood Detected" is announced whenever the sensors in the CS100 indicate the possibility of blood in the safety disc. This serious condition requires the operator to immediately check for blood in the tubing. If any amount of blood is noticed, stop pumping immediately and notify a physician. While awaiting the physician, it would also be wise to refer to the IAB catheter manufacturer's instructions for IAB removal and contact Datascope service. The alarm autofill failure, no helium occurs most probably when the helium tank is closed or empty. For this alarm, the operator should either open the helium tank or replace it with a full tank. We've now completed the survey of the CS100 system's alarms. While alarms signal a critical condition that must be dealt with immediately, these conditions can often be avoided by paying attention to alerts. Alerts are generated by the CS100 long before alarm criteria are met. Therefore, careful attention to alerts will prevent most, if not all, alarm messages. Alert messages are displayed in the Advisories section of the screen here. Some alert messages may occur in any of the operation modes, while certain alert messages only occur during auto and semi-auto operation modes. The alert messages that may occur in any of the operation modes are augmentation below limit set, low battery, low helium, and prolonged time in standby. The most probable cause of the alert augmentation below limit set is a drop in the diastolic augmentation below the augmentation alarm limit. This alert should direct the operator to assess the patient's hemodynamic status. Has there been a change? If not, the augmentation alarm limit may be set too high or too low. If the alarm limit is set too high, reset the limit to a range of 8 to 10 millimeters of mercury below the patient's diastolic augmentation pressure. Check to see if the augmentation control is set too low. If appropriate, increase the augmentation. The second all operations mode alert is low battery. The CS100 trips this alert whenever there is less than 30 minutes of operating time remaining in the battery. The operator should respond to this alert by verifying that the system is properly connected to an active AC power outlet and that the mains power switch, located here above the AC power cord connector, is on. The low helium alert indicates there are fewer than 24 autofills of helium remaining in the tank. This alert is initiated when the CS100 detects a drop in helium tank pressure that corresponds to a preset safety reserve level. In order to appropriately respond to this alert, the operator should verify that the helium tank is open. If not, turn the valve counterclockwise. Of course, the helium tank may be nearing empty. If so, replace the helium tank. The prolonged time in standby alert occurs after the pump has been placed in continuous standby for an extended period of time. The operator corrects this condition by verifying whether it is appropriate to resume pumping. If appropriate, press the Start key to resume pumping. We've now reviewed all the alerts which can occur while the CS100 is operating in any mode. Two alerts, poor signal quality and unable to update timing, can occur only when the system is in auto operation mode. If the poor signal quality alert is announced, the probable cause is that both the ECG and the AP signal quality are poor. To respond to this alert, the operator should attempt to improve the ECG signal by ensuring that the electrodes are positioned properly on the patient's torso and that they are making good contact with the patient's skin. The operator should also verify that the transducer is not left vented and check all cable connections. Finally, an attempt should be made to restore AP pulse height by flushing the circuit. The alert, unable to update timing, indicates a probable lack of quality in the waveform with poor augmentation. The operator should respond to this alert by keeping the CS100 in the auto operation mode while an attempt is made to identify the cause of the poor augmentation. Poor augmentation may be related to the patient or due to a kinked catheter and should be treated appropriately. This alert may also be related to pacing. Check to see if the pacer is being captured and sensed by the pump. Next, assess the arterial blood pressure waveform. If the AP signal is low or has no pulsatility, verify that the transducer was not left vented. Also, check the integrity of all cable connections. If the AP signal is noisy or there's artifact, find and correct the cause. Finally, if the heart rate remains sustained at less than 30 beats per minute or greater than 150 beats per minute, correct the heart rate. If the unable to update timing alert persists, the operator should switch to the semi-auto operation mode and verify timing, then resume pumping. Two further alerts can occur when the CS100 is operating in the semi-auto operation mode. These are irregular pressure trigger and verify proper timing. The probable cause of an irregular pressure trigger alert is due to the patient's rhythm being too variable for the CS100's algorithm to predict the systolic pressure trigger event when the pressure trigger has been selected. The most important thing for an operator to remember regarding an irregular pressure trigger alert is not to attempt to adjust the IABP deflation control. The system has automatically compensated by deflating earlier to avoid interfering with systolic ejection. The proper operator response to this alert, if the rhythm disturbance persists, is to consider using the ECG trigger mode for more reliable triggering. The last alert message to review in this program is Verify Proper Timing. This alert is caused when the operator actually switches the CS100 into the semi-auto operation mode, and as a result, the CS100 is asking for verification of the timing. If this alert appears, the operator should simply verify proper timing and adjust the inflation and deflation controls if necessary for optimal support. Then, press the Start key to resume pumping. We have now examined all the alarms and alerts that pertain to the operation of the CS100. One further communication the operator may see, however, is during demonstration or training of the system. A system trainer is available from Datascope to permit frequent review of pump operation and to train new operators in the hospital. The system trainer allows simulation of ECG and arterial blood pressure with varying heart rates, dysrhythmias, and paced rhythms. When the system trainer is being used in the CS100, the message System Trainer appears here on the screen. This is an example of a status message and remains on screen until the system is restored to actual therapeutic applications. The operation of any complex medical device always entails the applications of infrequently used functions, which may be appropriate only on rare occasions. Nevertheless, a competent operator must know that such functions exist and where to find them. The CS100 uses easy-to-navigate menus that provide rapid access to such infrequently used functions. All menus are accessed by pressing the menu guide key, shown here. Obviously, it's imperative when searching for an infrequently used function to find the menu that describes that function as quickly as possible. For this purpose, there is a reference to each menu and submenu located on the top of the pump console. The menu guide opens a choice window with a movable highlight bar that acts as a cursor. The arrow keys in the menu navigation circle control the movement of the highlighted bar. Open the desired menu by moving the highlighted bar to the menu desired. Then, press the key associated with that menu. To select an alternative item, use the up and down arrow keys. The CS100's dual trace recorder provides a hard copy record of patient waveforms. Several formats are supported. Select the format desired by first going to the User Preferences menu here. Then select the Printer Preferences submenu. Formats available are dual trace or single trace. Waveform choices are ECG, arterial pressure, and balloon pressure waveforms. At the completion of the recording, an annotated trailer is appended to the print. The annotation describes patient and system status. The format of the annotation depends upon the IAB assist frequency selection. When 1 to 2 or 1 to 3 is selected as the IAB frequency, the recorder will print both assisted and unassisted systolic and diastolic pressure information. To create a static printout, press the Print Strip key here. To create a continuous printout, hold the Print Strip key for 2 seconds. The associated LED will blink as printing continues. To stop a continuous printout, press the Print Strip key again. The CS100 is equipped with a Doppler sensor. The CS100's Doppler uses ultrasound techniques to detect vascular blood flow. To use the Doppler, first open the top storage bin here. The Doppler is located inside the door panel. Remove the Doppler from the storage bin, pressing the button on the tether to reel out or retract the Doppler as needed. Next, place a liberal amount of coupling gel on the transducer's surface or on the patient's skin. Turn the Doppler unit on and position the probe over the artery to be examined. Best results are obtained when the probe is held at a 45-degree angle to the surface of the skin. Now, listen for pulsatile blood flow and adjust the volume control here as needed. The CS100 Doppler has its own battery. If battery replacement is necessary, remove the cover of the battery compartment and lift out the old battery. Then install a new 9-volt alkaline battery. Since the CS100 is battery operated, it can be used in situations where the patient must be transported or where AC power is not available. Specific recommendations that should be followed when the CS100 is employed in portable operation deal with altitude changes, secure positioning, audio interference, battery verification, and console removal. Always be certain that the battery of the CS100 is fully charged and that a backup battery is available. If the transport will take in varying altitudes, such as over a mountain or in an aircraft, altitude changes must be addressed. Compensation for altitude changes are made automatically in the auto fill mode, but must be made manually in the manual fill mode. The CS100 system must be securely mounted and stable when used on an ambulance, helicopter, or fixed-wing aircraft. Caution: due to the high noise levels in many transport situations, the operator should continually refer to the operation screen and rely on visual alarm messages. During portable operation, the CS100 is powered by a rechargeable battery. Prior to portable operation, the battery should be fully charged. A fully charged battery is indicated by a continuously illuminated battery charging LED here on the front panel. The battery in use status message and the battery indicator are displayed here on the screen when the CS100 is operating from the internal rechargeable battery. When the battery has approximately 30 minutes of operating time remaining, the following occurs. An audible double beep alarm is activated for 30 seconds. The low battery, or EXT, alert message is displayed here on the screen continuously. The battery indicator here is displayed as empty and it starts flashing. The condensate removal module, shown here, will not operate. In order to make the CS100 easy to transport, the console has been designed so that it can be removed from the cart with or without the battery pack attached. When removing the pump console or the monitor from the cart or returning them to the cart, ensure that the wheels of the cart are in the locked position as shown here. Push the handle swivel release down and turn the cart handle counterclockwise. To remove the console with the battery pack attached, unlock the console by pressing the tab here on the right of the console release handle and pull the handle straight out like this. Lift the pump console straight up and off the cart. To attach the monitor to the pump console, detach the monitor from the cart handle by pressing the button on the rear of the monitor here and attach the monitor to the top of the pump console. Make sure the monitor is securely attached before moving the system. Extend the console handle until it locks into position. Tilt the system and pull to transport as shown. Weaning a patient from IAB support may be accomplished by gradually reducing IAB frequency, IAB augmentation, or a combination of both. When weaning, it is recommended that frequent assessment of hemodynamic parameters and patient condition is made. When weaning by reducing IAB augmentation alone, do not reduce IAB augmentation below the point at which movement of the IAB status balloon indicator is less than half. When the CS100 is not in use, the only maintenance required is regular checking of the safety disc. This procedure is described in the operating instructions shown here. This program has reviewed the initiation and operation of the Datascope CS100 as outlined in the abbreviated operator's guide. Anyone operating the unit should be fully familiar with the procedures described in the abbreviated guide and the operating instructions. Datascope pioneered the development of the first commercial intra-aortic balloon pump. Datascope's commitment to advanced technology, professional clinical support services, and information management tools will help your hospital maintain an effective, productive intra-aortic balloon pump program. The CS100's performance, reliability, and ease of use reflect more than 40 years of experience in balloon pump development and commitment to improving the quality of life of the IABP patient. Thank you for watching. Caution: U.S. federal law restricts this device to sale by or on the order of a physician. Refer to package insert for current indications, warnings, contraindications, precautions, and instructions for use.